Okay, so let's start, and I would like to welcome every one of you to this interesting guest seminar given by Radek Kapica from ABB. He's currently working as technology lead R&D for line hoisting and is a cybersecurity and technical solutions expert. And he will talk today about driving sustainability with smart automation and digitalization, which is a very exciting and hot topic in the society today. So welcome, Radek, and stage is yours.
Thank you. Yeah, nice to be here. I just told Michael, I think it was 26 years ago that I started my master's here in Sundsvall, then finished off in Luleå. Today's topic, driving sustainability with smart automation and digitalization, and how we at ABB look at this. Michael introduced me. Radek Kapica, been in ABB for about 20 years. Currently at the global R&D for Business Line Hoisting. And my role is solution architect and cybersecurity lead on in BL hoisting. The agenda for today, I'll start off with presenting ABB and ABB Group, a bit of history about us and how we work, and then go over to how we at ABB work with sustainability. And then move on to some customer cases when it comes to adapting to using renewable energy. And then from that move on to a bit about digitalization, automation, and also autonomous industry. And at the end, look a bit about on how the future and how we secure it. I mean, digitalization leads to that we need to expose the systems in a way. So cybersecurity is a big part of that. Okay, so first, ABB. ABB is a global tech leader in electrification and automation. Our mission is to enable a more sustainable and resource-efficient future with help of our products and technologies. And by connecting engineering and digitalization expertise, we're trying to help industries to run at a high performance and more efficient and productive and sustainable. That's what we call something is engineered to outrun. So having a high performant production that is also sustainable and efficient. And our purpose is to enable more sustainable, resource efficient future with the help of our technology leadership. And this by creating success for customers and addressing energy changes and helping industry to transform to being more efficient and likewise more sustainable. And we try to embed sustainability in all our processes and products and solutions. And to be a leader with technology in the specific electrification and automation area. So we see that our purpose and the custom offering that we have is quite well aligned with the secular trends that we see, where one of them is that there is a demand of more electricity. So we see that the demand is growing like 9 times faster than the total energy demand that is predicted in the coming 5 years. And this results in, there's about 70% higher average annual investments in electricity networks the coming 5-6 years. Then also higher energy efficiency, where about 45% of the world's electricity is converted into motion by electric motors, and yet only 23% of the world's electric motors are optimized through the control of drives. So we can have those run more efficiently and save resources that way. And then also we see that there are a lot of new energy sources coming in. So we see that the low carbon source global energy mix is to increase about 50% points from today's around 20% to 70% in 2050. And then the last trend we see, there's a shrinking labor force. So the number of working aged people between 15 and 64 per retiree, that is 65 plus years, is going to fall about 24% in the coming 10 years. So yeah, so either we need to do the process, the manufacture more efficient, or use less labor force, or try to change that trend of shrinking labor force. And then you also see some of our offerings. We want to reduce waste and increase circularity. I'll come into that more on the sustainability part. We're divided into business areas. So the business areas are electrification, motion, process automation, and robotics and discrete automation. Myself, I'm part of this process automation. And then each of those business areas are divided into divisions, as you can see below. And then further on, you have business lines on each division. And you also see that we are trying to maintain and trying to have a high global market position. So we're the second one on electrification, on the first on motion, and second on process automation and robot and discrete automation. So ABB has around 140 years of history. I think it's 104 here in Sundsvall even. So we've been around for a while. And those pictures are to depict, the first one is the first light in a train wagon, and the picture is from 1903. The second one is so this is supposed to depict the business area electrification. And the second one is motion. This is from a Strömberg company factory that manufactured electrical machinery and equipment such as generators and electronic motors. This picture was taken 1887. And then you see the next picture. That is a world's first electronically controlled robot, which was released 1974. And also we had the first world industrial painting robot in 1969. And then in 2021, we released our Yumi. That's the world's first truly collaborative robot. So where human and robot can collaborate. So you can see we serve customers in a wide range of industries. So everything from nuclear power plants, oil, gas, pulp and paper, that's mostly here in Sundsvall, and mining and minerals where I'm at. So I have a quite wide expertise in many different domains. And our people strategy is that we try to empower employees for large engagement and encourage innovative culture. So like our people to be innovative and think out of the box and see new opportunities. Grow. Each employees are free to take large responsibility for their own growth and how they choose to collaborate with other parts within the organization. And we also want to make an impact, so we work for a sustainable, equitable, and inclusive workplace and society where we operate. And some numbers. We're approximately 110,000 employees globally. We have 174 nationalities. And we have around or more than 170 manufacturing sites globally. We spend 1.5 billion on R&D investments. And we're right now at 21.3% of women in senior management positions, and we're trying to improve that the whole time. And in sustainability terms, we've reduced our scope 1 and 2 CO emissions about 78% since 2019. And also, you see that, it's a long history, 140 years. Okay, so how do we work with sustainability? So our sustainability agenda is to be at net zero carbon emissions at 2050. And we want to have a low carbon society. So we try to helping our customers to reduce their emissions. And when it comes to resources, we embed circularity in our projects and products. So we reduce waste, protect water and biodiversity, and try to use land responsibly. And we also promote social progress. So with partners, suppliers, and communities where we operate, we try to have teach them a large awareness of the environment. So promoting a more sustainable future. And here are some of our high sustainability targets and ambitions. So we want to reduce our scope 1 and 2 CO emissions by 80% till 2030. And we want to reach, as I mentioned, net zero by 2050. Also reduce our scope 3 emissions by 25 and be up to 90 by 2050. This is from 2022 then. And wanted to avoid emissions by 600 megatons throughout lifetime of our products. So we want our products to reduce emissions for the ones using it. And also have a more circularity approach in all our products and solutions. So we propose a refurbished product when replacement instead of a new one. Yeah, and then we also want zero harm to our people, and contractors. So we aim for a lost time for incident that is below 0.1. And then also we want to increase the proportion of women in senior management roles to 25% by 2030. But the biggest contribution is that we could do to a low carbon society is through our leading with technologies, and we've also set targets of helping our customers to reduce carbon emissions by 100 megatons till 2030. As I think I mentioned earlier, in the secular trends that we see, it's going for a more energy efficient future. So we see that there is more than 300 million of motor-driven systems in the world, and 70% of the electricity consumed by industries are using electronic-driven motor systems. And many of those run very inefficiently, are both old and not controlled by drives. So I think this could be both a profit and environment impact for the ones having them. So by optimizing and upgrading to higher efficiency systems, we see that we could cut global consumption by up to 10% within the industry. Am I running too fast? Okay, so adapting to renewable energy. So we see that the increase of electricity generation with PV and wind is increasing constantly and at a high rate. We also see that global battery storage have a record increase the last years by 136%. So more and more industries are adapting to using renewable energy sources. And one hot topic nowadays is hydrogen. So I'll show a couple of customer cases where they are trying to adapt to only use renewable energy for the production. So we could start with Luf. There's a small factory that produces hydrogen, which was commissioned 2021. They have 2.5 megawatts of wind energy that they use to produce green hydrogen. We've helped them so the complete system, both electrification and automation, is ABB. The next one is Skovgard Energy in Rame. This was commissioned 2024, and it's the world's first dynamic ammonia production. It uses 50 megawatts of PV or solar energy. They also have that combined with 6 wind turbines. And they are to produce 5,000 tons of green ammonia annually, which they see can prevent about 8,200 tons of CO2 emissions annually from being emitted. Then we have an upcoming H2 Energy that is to be commissioned 2027. They aim for having 1 gigawatt of wind energy. And with that, they want to produce 90,000 tons of green hydrogen e-fuel, methanol, and ammonia as well. So we see there's a big trend in going for renewables, and hydrogen is maybe a good way to start, because the hydrogen landscape is quite complex, but also flexible and can be very efficient. So, I mean, there's hydrogen production can use both renewable and fossil, but the big advantage is that the product of the hydrogen can also be used to capture CO2 emissions, so lowering global emissions by producing e-fuel with hydrogen. So can we reach where we use the renewable resource energy to produce hydrogen that we then use to produce e-fuel and also capture carbon? So that's a great win-win for both the industry and for the sustainability, or for the future environment. So yeah, this involves, I mean, a lot of different energy sources and also different applications or different end users. And hydrogen for e-mobility is to grow about 6 times coming years. I'll be coming back to this picture later on, talking more about the digitalization. So, yeah, digitalization and automation, and also autonomous industry. So ABB have a unique position. We have a lot of digital enabled devices. We have about 70 million plus digitally enabled devices out, and then we have 70,000 digital control systems on market, and 6,000 enterprise software solutions, and also 220 cloud applications out there. So I have a deep domain knowledge, industry and process knowledge and expertise. As you saw earlier, there's a lot of different domains we operate in. And with those figures, we have an unmatched digital footprint and industrial data learning. Our products are very open, adaptable, and vendor agnostic, the technology stack we use. And we promote having customer collaborative development, solving their complex business cases and technical challenges. So a bit of the digital history and automation part of it. In 1960s, we started to use microcomputers for the signal processing. Before that was mostly analog. 1970s and 80s started to replace controllers and the panel board functionality with more computer-based solutions. Then 1980s was the start of using more PLCs and integrating those into what we call DCS. It's distributed control systems. And that's also when we started to see what's now called OT and the networks for the OT operational technology. Then this shouldn't be there maybe. 1990s, it expanded, and the OS was more going into an IT, the same OS as IT is using, and hardware also shifted, and there was more and more DCS systems and PLCs that was combined. And today, we're continuously connecting systems and data that runs automatically to improve operations, and also aiming for and using having autonomous in the industrial system. So here's just a bit different way to see how it's been evolving, and also how the IT has lived by itself, and OT as well, but in the late years been converging into, it's been, you started layering it up, the architecture, and dividing the OT into different layers. Then it started more and more, you started using more and more technology that was more aimed for IT. Now you started to implement that on the OT as well. So it converged more and more, and it's more going to using the same technology as IT is using today. So that is also used in OT. It's things as AI, machine learning, and stuff like that maybe wasn't in OT before, but starts coming in there, and we see a connection between the IT and the OT environments. So here they call it automation. I don't know why, but it's more, it's autonomous, how to go from automation to having automation more autonomous. So if you look at automation, I mean, it's a fixed behavior. In a PLC that you run, you have something you need to sense. For example, if you have this motor that's running too fast, you sense that. The PLC or the controller decides to reduce the speed, so it analyzes that, and then the current is sent to the motor, and the motor slows down. And it's always the same fixed pattern that happens on the automation layer. But when you start applying AI and machine learning on that, you have a different shell upon that. You still have this, you still need to do this fixed behavior, but you maybe need to perceive what's and see what's happening in the process, and understand what corrective actions you should take, and then solve it. So it becomes another feedback loop that's surrounding this OT part, and that's what they in this call automation, but it's more of using AI models and machine learning upon automation. And I mean, autonomous operations can be divided. I mean, you don't have to go from just letting everything on the machine learning. You could divide it in such a way that you have a solution provided by AI model or machine learning model, which you approve and then act upon as a human. Or you could, first of all, you could have different kind of solutions maybe provided to a human. The human decides which of those to choose and then acts upon that. But then you could reduce the human interaction more. So you have the AI and machine learning to decide which of those solutions are the best, and then just having a human confirming that. So okay, let's go on that. That's what we call augmented operations. So we augment it with the help of AI. And then going to totally autonomous operations, there's no human involved. So if we go back to this hydrogen landscape, I mean, it's quite a complex and with a lot of different streams and a lot of different products. And I doubt it would be possible to have this up and running in an optimized and resource efficient way without anything more, with only automation. So if we just look at where we see that we could use some kind of digitalization or machine or AI models or different models. I mean, we maybe want to forecast how we could use the renewable energy sources for an optimal production. Then also we need to have maybe forecasts from our systems on which product we should produce right now at the lowest price, and maybe also with the lowest CO2 footprint, depending on what customers requires. And then also the most important, maybe, to have this run as efficiently as possible. One of those could be that we use AI and machine learning models for a predictive maintenance to have the process being optimal and having an optimal performance. So in terms of ABB and software and digitalization and AI, we have around 50% of more than 50% of our R&D employees are in software development. That's where we put a lot of focus. And we have more than 250 AI-focused projects running across the ABB group today. And our strategic priorities is to increase the digital content in our offering and also embed more and more software into instrumentation and whatever to be a differentiator in that. And we also continuously develop software and digital services organically and try to do bolt-on acquisitions when we need. So if we just take a quick look at how our orders are spread. So 83% of the orders we receive are on products and solutions, and 17 on services that we provide. And when it comes to digitalization and the software that is digitally enabled and products and services, it's around 60% of all those orders are digitally enabled products and services. So with digitalization, machine learning and all that comes some challenges. So let's see, just a small, a few attacks, maybe not in recent time, but just on kind of industry, and we see hackers try to poison water in Florida. We also had this was 2015, but there was a big cyber attack on electrical grid in Ukraine, where I think it was 225,000 Ukrainians that had a power outage. And then also, I mean, in the manufacturing, we had Toyota that had a big supply chain attack, which resulted in that they needed to close 14 factories for about 24 hours, which is a huge loss of production. And so, cybersecurity and the challenges with that. And when we see that cybersecurity is to reach about $10 trillion by this year, actually. This costs organization a lot of money, so about 2,265 billion annually. And the cybercrime is to grow, and it's expected to grow about 50% year on year for next 5 years. And in average, it takes organizations about 277 days to identify that there have been a breach and to contain that. 75% of OD organizations have had 1+ intrusions the last year. So it's quite a big number of intrusions. And 48 of those were more than 3+ intrusions. The attacks impacts almost 61% of the attacks aim for OT systems, for the automation systems, just to cause, as we saw earlier, outages, loss in production as Toyota's case, and more. So what are the costs of not addressing this? I mean, it could be as the Florida case, you could put workers you could, I mean, when it comes to OT, you have a lot of big machinery running, and if you suddenly stop that, maybe you could harm workers, have serious injuries, or even cause death on the site in the production. As the Florida case, you could risk that you release hazardous materials into surrounding environments. You could also risk production disruptions, which of course results in loss of productivity and financial implications. Or you fail to meet security standards and compliance, which leads to fines and sanctions from regulatory bodies. So one finding we see that one of 3 topmost barriers for improving sustainability with digitalization is the use case is too complex, or the one in implementing has a lack of skills to do it, or cybersecurity, where cybersecurity actually is the biggest one. So that's why a lot of companies kind of waits out the digitalization and won't start working with sustainability because of they're afraid of cybersecurity. So I just have a brief how we at ABB see you could reduce your risk for cybersecurity in a brief way, and what we see needs to be done in industry to reduce the effects and also reduce the risks for being hacked. So what we try to help our customers is to first of all assess what do we have, what risks do you have with your current setup, how could we plan for having this more secure in terms of maybe network architecture, or even different operating systems or whatever. And also we have our own reference architecture for having a secure OT environment, how things should kind of talk between the different layers to have it secure. Then we help our customers to implement that, where some of those things are helping them, just malware protection, security updates, having all systems updated, having backups in case of you get ransom. You want to be quick on getting back into operations again. Then system hardening, another layer to just harden how things communicate with each other. And then application allow listing, so just allow the applications that are really needed. And also have some, I mean, a lot of industries they don't even know what assets they have on their network sometimes. So, do we have this one? Okay. So yeah, that's a very important part. Have a inventory of what assets do you have and what do they communicate with. And then, just to sustain this mode, I mean, you need to have ongoing maintenance. I mean, security updates and backups are something that you need to work with the whole time. Also, you need to train the personnel to know how to have things up and running and also up to date. Then one big thing is to have event monitoring, so you see when abnormal events happens in the system, and also not just how applications access something, but also what communication is there on the network, so you can see patterns that are abnormal and fetch that. And then also you have to have some kind of operations, how to handle this. And then also how to handle if there is a breach, how do we handle that? So we could reduce this time, as we saw earlier, 270 days. That's quite a long time for someone being in your system and collecting data or whatever. Summary. What the findings is with sustainability and digitalization is that what happens to be good for the planet can be good for profit as well. So, I mean, an operational efficiency, safety, and then if you optimize your energy and resource consumption, I mean, that's a win-win for both the environment and for the business. Economic and environmental gains doesn't have to be a trade-off. It can be a win-win scenario. And we see that it's easier to implement sustainability with digitalization if sustainability is the key driver of this. I think that's in here. Yeah. So if a company sees sustainability as a target and have that as a driver to implement digitalization, we see that a lot of those projects succeed. And you also need to address cybersecurity with this. So, and just to say that sustainability doesn't have to be boring. So we're we're partners with the Formula E, where we want to bring electronic racing to many people as we can, and show that driving can be both exciting and sustainable at the same time. Yeah, that's me.
So thank you, Radek, for this interesting presentation, and I hope you learned a lot about ABB. And as you see, it's a huge company, a lot of innovation taking part in the company. Since I have been working there as well for nearly 10 years, I know that sometimes they are actually ahead of us in academia as well. So, yeah, that's true. But I think we have time for a few questions from the audience. Is there someone sitting on an intriguing question to Radek here? So please, go ahead.
Sure.
The sites, of course, ABB is very wide area. Yeah. So of course, ABB covers a lot of technologies, but I was wondering a bit, besides cybersecurity, what kind of technology challenges do you currently see as kind of like hinders for digitalization and for autonomous operations of, for example, your area in mining, for example?
Tough question.
Starting with the easy ones.
I don't know. You mentioned cybersecurity, of course, but I think that's the biggest one, because when we want to implement, and of course this is depending on the region, but some regions are very strict, and we're lucky that ABB's or Sweden is not that. It's very forward in that part, so it's easy to implement digital services and stuff that sends data to the cloud. But if you go for Canada, US, and China, there is a big no to send something to the cloud, and so I don't know. I think in terms of digitalization and maybe using cloud, then it's the cybersecurity part that's the biggest. And otherwise, sometimes you go to an organization and they've been working with only automation and have no knowledge of IT, and then to start implementing just simple AI models or something that is running on the edge is hard, because they have this big gap between their IT and their OT personnel. So that could be a big challenge.
Stephanie?
Thank you. It was actually my question right now. It was about the customers. If you noticed any change in the last, 12 years maybe, in the acceptance or among customers. I'm not only talking about Sweden, but globally, in how, in, for example, both if they accept new ways of controlling with respect to AI, and because now it's been more generally known that you can use AI for a lot of things. Also probably in the customers that don't have that IT knowledge, they are they've heard about AI. So I was thinking maybe that has been changed a little bit. And also I was thinking about the, with new technology also comes the cybersecurity. How do you deal with educating more or less the customers? Because it's really it must be a big challenge, I think.
Yeah, it is, and that's why it's part of this journey. You saw that is education is on there, so that's a big part to have but a lot of bigger at least organization have their plan for just how probably you also have this how you should handle USB sticks and all of that, and being curious of try to avoid emails that doesn't fit the normal pattern, so to speak, so not going into links. But so I think the smaller companies have a problem still there. They don't have that big knowledge in cybersecurity now, and especially in remote locations where you have mines often. Then there's no if it's not a big enterprise, they maybe don't have that big knowledge of cybersecurity.
So do you kind of say no to those customers?
No,
you can't buy ABB stuff.
No. I mean, that's why we have this so we can educate them in more of course on the OT part, but still, I mean, now when it's converging, we try to have that built in our trainings as well. So yeah, and a general thing we see, but that's most for the smaller companies. They accept having a lot of IoT devices all streaming directly to cloud, while bigger enterprises see they want to have control. They just don't want to know that it's a big. I mean, that there's a lot of different nodes. They want to have it concatenated in a way to one node that is the edge node that is controlling this. So they have, so it's easier for them to monitor what they actually send to cloud, because a lot of the big enterprises, they just want to maybe from the beginning, as what we see, they want to send KPIs that doesn't tell that much of what's their maybe traded, some secret, from how they have their process set up or something. That data, they don't want to disclose that data, so they try to just have KPIs at this moment. That's what I've seen, at least.
Okay, do we have some more questions for Radek? Yeah, we have Ching.
Okay, thank you for the presentation. I mean, recent years, sustainability has been drawn more and more attention in both industrial and in academia. But I mean, I still wonder that do we have any clear definition of the evaluation on the sustainability?
Clear way to validate, you mean?
Yeah, I mean that's it's. Sustainability, that word, I mean, it looks like it may have quite a broad content. Mm-hmm. So, and do we have any quite clear definition of how we evaluate the sustainability level?
Yeah, I mean, that's what in this presentation we try to set at least a date where so you can compare between those dates we have done a reduction, for example, in CO2 emissions or and also instead of giving the customer the opportunity to buy a new product, if we have a refurbished one, we prefer to say to them to just have this circularity. So in some way that is a win-win. So we don't need to produce that much new because there's always someone upgrading their system, and then we buy back that old system, so we can use that as refurbished parts. But in terms of how to in a way validate it's a tough question, because the biggest is CO2 right now, seen as a way to be sustainable, to not just throw out a lot of carbon dioxide in production and products when they are produced, and also in projects and so on. So
I see time is flying. I have then one, let's say, final question. Sure. And you showed the slide with different field bus technologies. So I would like to ask which field buses are, let's say, the most prominent use today, and what kind of trend do you see? Do you see still that Profinet will be used forever, or is it industrial Ethernet coming? And secondly, how does customers see upon 5G, which has been marketing? If you look at Ericsson, it will solve all the world's problem and industrial use cases. But how does the customers really see 5G?
Yeah, good question. When it comes to the field buses and that, I would just say generally what we see is that it goes to more Ethernet based. But then if it's Profibus, Profinet, or if it's Ethernet, I don't think that's could maybe vary between regions. It's mostly that customers that used to have Profibus go for Profinet, and I mean we have products that support both, but I don't see any clear kind of direction there where it's heading. But of course, wireless is more and more coming more and more, and 5G. Yeah, that's what I tried to explain before, that the big enterprises that I've been working with, see they are a bit reluctant to using 5G because they don't have that kind of control of what it's sending and where it's sending that data, and yeah. So I don't know. I think there are probably a lot of applications where that is the best way. So, we talked earlier today about maybe positioning or something like that, but maybe not as sending that the kind of the data that sensor has, because then you also need to go back to the control system or the edge to compute that. So yeah, I don't know if that answers your question.
Yeah. So thank you. So once again, a big applause for Radek taking time to visit us.
Thank you.
So,
Good.
for attending.
Yeah, thank you. Ja, vart är den?